So guys, hello and welcome back to your own channel Wisdom Bloom. So in last lecture we have covered up to the neutralization according to Arrhenius theory. So in this lecture we will be continuing after that. So limitations to Arrhenius theory. Arrhenius could not explain the acidic nature of substances which don't contain hydrogen like SO2, CO2 and SO3. So, we have learnt in Arrhenius theory that an acid is a substance that contains hydrogen and is able to liberate hydrogen ions when added to water. But in this theory, there is no place for such compounds with an acidic nature which does not contain any hydrogen ion or any hydrogen atom and which cannot liberate hydrogen ions when added to water. And bases which don't contain OH negative ions or hydroxide ions also could not be explained by Arrhenius theory like calcium oxide and magnesium oxide. We have learnt in Arrhenius theory that a base is a substance that contains hydrogen and is able to liberate hydroxide ions when added to water. But there are some bases like calcium oxide and magnesium oxide which does not contain hydrogen at all and cannot liberate hydroxide ions when added to water. So Arrhenius failed to explain the above two things. Now, Arrhenius' theory was only confined with aqueous solutions. So, acids and bases in non-aqueous medium could not be explained by Arrhenius' theory. This is very important that Arrhenius' theory was only confined with aqueous solution, right? And Arrhenius' theory failed to explain neutralization without the formation of water, like CaO when reacts with CO2 and forms CaCO3. Can you guess what kind of chemical reaction is that? It is a combination reaction. So Arrhenius told that in neutralization an acid and a base react together to form salt along with water. But we can clearly see that in this neutralization reaction there is no salt formed. So Arrhenius failed to explain such neutralization reactions. So we have covered limitations of Arrhenius theory. As per promised, we will do causal Lewis theory and Bronsted Lowry theory, but we will do that after we complete the entire chapter, right? So, we have come to a question that what is acidity and what is basicity. By name, we can guess that acidity is a property of acid and basicity is a property of base, but it is not like that. You will be in a surprise that acidity is a character of a base. Yes, you heard me correct. Acidity is a character of base. Acidity of a base means the number of hydroxide ions a base could produce or liberate in aqueous solution per mole. And basicity, in contrast, is a character of an acid. Basicity is the number of hydrogen ions an acid could liberate in aqueous solution per mole, right? So examples of basicity of HCl is 1, right? If 1 mole of HCl is added to water, it can release only one hydrogen ion. And acidity of potassium hydroxide is also 1, because if 1 mole of potassium hydroxide is added to water, it can liberate only one hydroxide ion. Now classifications of acid. So we can classify acids on various criteria. So the very first criteria is on the basis of strength. On the basis of strength, we classify acids in two groups. The first is strong acids and the second is weak acids. And on the basis of basicity, which is the second criteria, we classify acids in three major groups: monobasic acids, dibasic acids, and tribasic acids. On the basis of concentration, which is the third criteria, we group acids into two groups. The first is concentrated acid and the second is dilute acid. You are very familiar with these two groupings. Now, on the basis of volatility, there are two groups. One is volatile and another is non-volatile. So, on the basis of strength, those acids which ionize completely in aqueous solution are called as strong acids. As I have given the example that hydrochloric acid and sulfuric acids are very strong acids because they ionize completely when added to water. Their ions dissociate completely or differentiate completely. But as in the case of CH3COOH, it is a weak acid because it ionizes partially in aqueous solution, right? And on the basis of basicity, there are monobasic acids. What are monobasic acids? Those acids which can produce only one hydronium ion per mole is called as monobasic acids. Now, you might be thinking that what is hydronium ion, right? So, in Arrhenius theory, we got that an acid can produce H positive ions when added to water. So, when added to water, H positive ion combines with H2O and forms H3O positive. This H3O positive is called as hydronium ion, right? So, now we come to dibasic acids. Dibasic, by the word di, you can refer to two. Those acids which can produce two hydronium ions per mole are called as dibasic acids. Remember that H positive ion is not hydronium ion, H3O whole positive is hydronium ion, and OH negative is hydroxide ion. So, those acids which can produce two hydronium ions per mole are called as dibasic acids, right? And tribasic acids, those acids which can produce 3 hydronium ions per mole are called as tribasic acids, right? I think it is very clear to everyone. So we move forward, and on the basis of concentration, it is very simple. Concentrated acids and dilute acids, those acids which have greater quantum of solute than solvent in an aqueous solution of acid are called as concentrated acids. Now, what do you mean by quantum of solute? Here, quantum means the quantity. If the level of solute is very high in solvent, it is called as concentrated acid. So we know that in a solution there are two things. One is solvent and another is solute. For an example, if I make a solution of sugar and water, sugar will be the solute and water will be the solvent, right? So as same, if there is a solution of HCl and H2O, H2 is the solvent and HCl is the solute. If the level of HCl, that is a solute, is very high in the solution, then we call that concentrated acids. And if the HCl or the solute level is pretty low in the solution, we call that dilute acids, right? And on the basis of volatility, what do you mean by volatility? Volatility is a property of a substance when it vaporizes below its boiling point, right? So volatile acids, those acids which vaporize under 100 degrees centigrade are called as volatile acids. Now why 100 degrees centigrades? Because we know that all acids we are talking about are aqueous and the boiling point of water is 100 degrees, so we consider volatile acids that vaporizes under 100 degrees centigrade, right? Examples of volatile acids is carbonic acid, and example of non-volatile acid is sulfuric acid. Now, classification of bases. As same, on the basis of strength, there are strong acids and weak acids. Sorry, strong bases and weak bases. on the basis of acidity, monoacidic bases, diacetic bases, triacetic bases, and polyacidic bases. And classification of base on the basis of concentration, there are concentrated base and dilute base. So on the basis of strength, strong bases, those bases which ionize completely in aqueous solution are called as strong bases. As same like NaOH. NaOH when added to water completely dissociates into its respective ions, that is Na positive and OH negative. And weak bases are those which cannot ionize completely or they ionize partially in aqueous solution are called as weak bases, right? So on the basis of acidity, we have monoacidic bases. Those bases which can produce only one hydroxyl ion, sorry, it should be hydroxide ion, per mole in aqueous solution are called as monoacidic bases. You can also call that hydroxyl ion, no problem. And those bases which can produce two hydroxyl ions per mole in aqueous solution are called as diacidic bases, right? Those bases which can produce three hydroxyl ions per mole in an aqueous solution are called as triacidic bases. Okay, you just cut this R and make it mole. Per mole in aqueous solution are called as triacidic bases. And what are polyacidic bases? Those bases which can produce 4 or more hydroxyl ions per mole in aqueous solution are called as polyacidic bases. So on the basis of concentration, there are two kinds of bases. One is concentrated base, another is dilute base. Just like the acids, if the level of solute, that is the base, is very high in the solution, we call that concentrated base. And if the level of solute is pretty low in a solution, we call that dilute base. For example, you have concentrated NaOH whose pH value is almost 14. It is an concentrated base. It is a concentrated base because the level of solute, the level of base in the solution is quite high. But if you add water to it and make it such that the pH value gets down, decreases up to 8, then we will call that a dilute base, right? So for today, up to this much only, and thank you all for watching this video. And if you are new to our channel, please subscribe our channel Wisdom Bloom. Here you will get all such kind of videos which will help you in your academics, right? In our next lecture, we will be dealing with the chemical properties of acids and bases and some chemical reactions. You have chemical reactions in your NCRT which are very important from exam point of view, right? So we'll be dealing with all that in the next lecture. So thank you all. Bye bye.